Hello everybody, it is 2:31 p.m. and we are going to analyze the crystal growth, alum crystal growth. So, as you can see, this is the glass vial with the solution, the saturated alum solution, 1:22, 5 p.m. It is 1:25, 2:32 p.m. So it has been about almost 3 days, and there is no visible sign of growth. If you can see that, maybe some in the bottom, but doesn't look like much. Reason for this is not enough time has passed since the experiment was started. The whole experiment was meant to last 3 weeks. It's only been 3 days. Alright, so how did we grow the alum crystal? First of all, we dissolved some scrap aluminum foil and 9 molar KOH, potassium hydroxide. We made sure to break up the foil as more surface area would allow the reaction to proceed more quickly. Potassium hydroxide reacted with the aluminum, creating bubbles and intense heat. My lab partner and I waited until the reaction has ceased before moving on, and we knew that when no more hydrogen gas was emitting from the beaker. Alright, and then we proceeded to remove any excess solid precipitate from the beaker through vacuum filtration. It's a very simple method. You take a filter flask and you attach a vacuum tube to it, and you pour everything through a Buchner funnel, and the vacuum forces the solution through a filter. Next, we prepared 25 milliliters of 9 molar sulfuric acid, and this acid was poured into the filtered solution. So note that the filtered solution is now AlOH4- or aluminum hydroxide. Okay, so we took 9 molar sulfuric acid and poured it into that solution, and we noticed crystals forming after several minutes. This is solid aluminum hydroxide. After we finished adding the 25 milliliters, we then proceeded with stirring and heating the solution a little bit to make sure everything has dissolved. So note that solids started forming after we poured in the sulfuric acid, then we heated and stirred in order to make sure everything is dissolved. Note that the choice of solvent and solute is critical because both are soluble at higher temperatures, which means they dissolve, and at lower temperatures the solvent remains soluble, but the solute is not. It appears crystals. This leads us to our next step. We put everything into an ice bath and we watch the crystals form as the temperature is lowered. Then we rinse the crystals 3 times with 50-50 ethanol water mixture, each time drying the rinse through a Buchner filter. We then measured 5 grams of the crystals approximately and mixed it with about 40 milliliters of water. This was determined based on the solubility of the crystals, and this creates a saturated solution. Alright, and then we split it up between my lab partner and I, and we each have half of it. Okay, so how do we grow table salt crystals? Well, it's actually very simple. You heat a pan, you fill it with water, okay, about half a cup of water in the pan. You pour in some table salt, about 1/4 to half a cup of table salt. You pour the water into a clear jar, dangle a string from a pencil, put the jar in a safe place, and wait for salt crystals to grow on the string. It'll probably take a few days. Alright, and how do you grow a sugar crystal? Very similar to growing a salt crystal. You just want to boil some water. Okay, the water probably needs to be at a higher temperature than when you're growing salt crystals because sugar needs to be soluble. It can only dissolve at a higher temperature. So you pour in the sugar until you see it accumulating at the bottom of the pan. Then that means you have a saturated solution because the sugar is no longer dissolving. It's actually super saturated. But it will be saturated because when you pour the water into the clear jar, make sure not to pour any of the sugar at the bottom in. Once again, you dangle a string from a pencil wait a few days and you'll see sugar crystals growing on the string. Thank you very much for listening.